While I was working on this, I developed a little round robin, poor man's round robin scheduler. Okay, so I have some periodic things that the code needs to do. It needs to blink the heart. It needs to blink the LED for a heartbeat, and it needs to draw samples once a second, and I need to respond to people pressing a key on the serial port. And so the original code, it was all like inside a loop. Inside of the loop method, I would call the blink routine. I would say inside a loop, is it time to call the blink routine? Call the blink routine. Is it time to draw a sample? Draw a sample. Is it time to check the keyboard? Check the keyboard. And this was all like inside of the loop, and that's just messy. So after successive attempts to clean up the code, I developed just a simple class that where I can say write the method for the blink. It's a function, right? It's kind of C-like right now. So write a function for blinking, write a function for drawing a random number and whatnot that I need to do, set the colors, da, 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 da. Write a function that checks to see if there's a keyboard key hit, and if so, process a command. And so what I did was, I've got these three functions. I've got a class where I can say, here, take this function and execute it every X milliseconds. Take this function, execute it every X milliseconds. Take this function, execute it every X milliseconds. And then I have a method of that class that loop calls at the top of the loop that says run whoever is runnable. And so that method will take the current time and see in order. So it's kind of round robin. It'll look in order. Are you ready to run? If so, I'll run you. Are you the next guy, is he ready to run? If so, I'll run him. Next guy, etc. So it got me thinking, I could make that even look nicer and look more like C++ if I had my little coroutines as classes. So I could clean that up a little bit more. But then I started thinking about, why don't I do actual coroutines? Now, there's no support in C++ up to 14. There's no support for coroutines. C++ 20 has some support for coroutines. Now, coroutines would be where they cooperate with each other to say, I'm going to yield, and it yields to the next guy, and then the guy yields back, that kind of thing. I didn't like the stipulations for C++ 20 what the coroutines could do. Like, for one thing, they can't call a constructor or a destructor, and I am like, and there's other things they can't do, and it's like, it's too limiting. And I was thinking today, just pondering, why don't I just write a little round robin ish coroutine scheduler that I can just drop in and say, then I could write code where I say, I'm going to yield for a second. And the little kernel of the scheduler will say, okay, put him on the shelf, and now activate the next guy in the round robin. See if let him have control for a while until he yields. And then do the next guy until he yields. And I came up with a scheme for doing this so that it fits in Arduino land where loop still works. Okay, so you could still have your code in loop, but you have a little hook at the top of loop that says, go take care of the coroutines and then do loop. Okay, so it's going to involve doing some machine or assembly, messing around with the stacks. Okay, so I have some experience with this because I wrote a fourth interpreter for a very simple fourth interpreter for the Cortex-M4, where you could take your fourth routine and compile it into Cortex-M4 machine instructions. So I learned how to, use the stack and, how a machine language bit of code, like I wrote a compiler, okay? So, how a little machine, simpler than a full compiler because it's just fourth code, because fourth is simple. Push, pop, add, subtract, simple things, right? But I learned how to, like create machine code and execute it and let it use the stack and return and all that kind of stuff. So I thought, hey, I should be able to do this. I could have a class per coroutine, and each routine could have its own stack, and I should be able to have a kernel where it launches into one of them, and when he yields, he comes back and that guy switches the stack pointer to this other guy's stack, returns to him. And basically, as long as they're yielding to each other, or just yielding in general, control will flow around. And I'm going to make that a separate project that I'm working on, when I'm too overloaded with thinking about random numbers. So I might come out of this. So it's just kind of like playing with random numbers and trying to do things in C++ made me think, hey, I could write a little coroutine facility for Arduino. It should work, definitely for the Cortex-M4. I know I can do it. And then for maybe AVRs, I have some. So maybe I can learn how to play with the stack with an AVR and have it support AVR. So that might be coming along down the line in a future video. Goodbye for now.